Alright guys, these are some homework examples from 4.3. 4.3, we're looking at the probability of multiple events being joined together with the word or. So like the probability of A or B. So here's a question from your homework. We're also looking at complements here. So if we're told an event has a probability of 0.96, to find the probability of the complement, remember the complement rule is to subtract from 1. So it's basically saying that one of these two things have to happen. Either this thing that has a 90% chance of happening, or 0.96 probability of happening, or the complement would be 0.04, the thing that when you combine it with the other one you get a certainty of 1. So just 1 minus the probability of A is the probability of A complement. Alright, and then B, this is a theoretical one. This will be like more an empirical approach. A certain group of women have this percentage rate of red-green color blindness. If a woman is randomly selected, what's the probability that she does not have red-green color blindness? So that would be 1 minus the probability that they do. So if I write that as a decimal, because it's a percent and we change to a decimal to do math, we get 0.9961 is that probability that they don't have red or green color blindness. Okay, so 1 minus the probability of A is the probability of not A, or the complement of A. Alright, this one's going to use this rule of OR for OR probabilities. The following data set summarizes the results of 1,071 pedestrian deaths that were caused by accidents. Okay, they want to know if we pick one of these deaths randomly, find the probability that the pedestrian was intoxicated or the driver was intoxicated. Okay, so when we see that word or in there, then this applies if it's within the probability we're being asked to find. So this is pedestrian, I'm going to put P, or the driver, D, was not intoxicated. Oh, sorry, pedestrian was, or the driver was not. So I put a little line over it, meaning was not intoxicated. Alright, now according to this, that means that's the probability the pedestrian was plus the probability that the driver was not minus the probability the pedestrian was and the driver was not. Okay, and we break it down into these simple groups because it's easy, especially from a table, to find these individual simple events, probability. And of the compound events, like meaning we're grouping more than one together, it's easy to find an and versus an or in a table. It's just the intersection of those. So the probability a pedestrian was intoxicated is the sum of these two, 375 out of the 1,071 total, plus the probability the driver was not. The driver is intoxicated, no, that's this many, so that's 896 right out of the 1,071, and then we subtract that they both were. Alright, why are we subtracting this? It's because when we added up these pedestrian drivers that are pedestrians that were intoxicated, that was these two values. Okay, the drivers were not, that was one of these values. Okay, these two values. So this 300 got counted twice. It got counted here for the pedestrians intoxicated, it got counted here for the driver wasn't. So this 300 is overcounted. So we subtract it off, but we see where it is in the table, P and not D. Pedestrian yes, driver no. So where they intersect is at 300. Alright, then if I add those and subtract, these are just the numerators since the denominator is common. That's 971 over 1071. So if I divide that by 1071, I get 0.9066. So 971 over 1071, which is approximately 2 3 decimal places, 0.907. So that's how we use this OR rule, especially from a table. Now I want to show you, because of this little bar or this little box right here, that means we can copy this from Excel. So this is the homework as it looks online. Slightly different numbers for this example, but notice this box here. We talked about it before. If you click it, it brings up the copy to a clipboard option. If we copy it to a clipboard, we can then transfer this over into Excel. So I'm going to go into this first cell, paste the data. Alright, I'm going to give it some room. Alright, so we can see what's going on. And then here, if I highlight these two and press sum, it adds those up. If I highlight these two, press sum, it adds those up. If I highlight these and press sum, it adds those. And then for this last cell right here, you just need to type it in. You just type in equals sum, parentheses, and then click. You either click here and here. Alright, that's D2 and D3, or you can click here and here. Alright, B4 and C4. That would also get you that same number. So there's our total, and then if we go back and look at our probability that we're being asked to find, it says to find the probability the pedestrian was intoxicated or the driver was intoxicated. So one or the other was intoxicated. So if we go back over to our table, you don't have to do this via the formula. You can do it intuitively. If one of the two has to be intoxicated, here's the total where the driver is intoxicated. Alright, if I highlight that yellow, alright, that's part of what considers one of these two intoxicated. And then this, the pedestrian intoxicated, this is the only cell that hasn't been highlighted yet that would make the pedestrian, or it would make one of the two intoxicated. Okay, this 68 would have been our overcount if we used the formula, but just something in one of those yellow regions is something that satisfies one is intoxicated or the other. Right? I know that these two sum to 129. I know that these two sum to 365. So I could either use this and add the 61 to it, or I could use the 129 and add the 297 to it. But it doesn't matter. I think, in my opinion, the easiest way is just write equals sum, and then just click these three cells that we got highlighted in yellow. This one, this one, and this one. Add those together, I get 426. So 426 over 985 is my probability, but they want it in decimal form rounded, so I'm going to write equals 426 divided by 985 is my total. Hit enter. So 0.432 3 decimal places. Alright, and that's how we use that table feature on the calculator. On the Excel. To do those. Alright, it's fine, you can do it by hand, you can do it either way you want to. Alright, last example, another OR probability. Find the probability in this table below getting someone who is in group AB or type RH negative. Okay, one or the other. So again, if I'm going to take, there's 100 types of 100 people, these add up to 100. So OR means you have to be in this row, or you have to be in this column, or in this row. Well, this 8's already been accounted for, so instead of overcounting and putting the 8 in this row, I'm just going to add these additional numbers to it. Alright, and so I end up just adding 5 plus 6 plus 1 plus 8 plus 8. So that's 28 out of, and then if you take that number and add the other three numbers that are on there, it should get 100. So 28 out of 100 is the total. Alright, that equals 0.28. If you have to make it a fraction, then just press math 1 to change it to a fraction. So 7/25 or 0.28 is our answer. So we just again added these together. That's where that 28 came from. Alright, and then we reduced it, so that's 7/25 or as a decimal 0.28. Alright, 28 out of 100, 0.28. Alright, so these are just some examples of what you'll see in your homework. Just know with these tables, you can do it intuitively and avoid you having to do the formula. Just make sure you don't overcount anything. That's why I stopped here and didn't count the 8 as well, because I would have to go back and subtract it off according to this formula. Okay, so see how you do it with it. If you need some help on them, just click that icon that says Ask My Instructor for help.